Hey everybody, this is Larry. This is day 8 of the Leetcode Daily Challenge for March. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. And honestly, today's poem is 875 Koko eating bananas. We'll also be doing the weekly premium problem, so definitely check that out afterwards. Today is Koko eating bananas, and apparently it is a very famous Leetcode problem. I didn't realize this the last couple of times I solved it, but apparently that's the case, so definitely check that out. It is going to be a binary search, a little bit of a spoiler, and basically the idea behind this, and I think I actually recorded this as one of the canonical binary search tutorial video. I need to put that video out. Let me know in the comments if you agree. But basically, the thing that makes this a little bit different, though I think we did it yesterday anyway, so maybe at this point it's not, but it is one of the representative prompts that sorry, just getting my notebook ready, for binary searching on the answer, meaning that you don't know what the answer is, but you're trying to figure out, is there a way to figure it out without checking every number, right? And here you want to see you want to check k, right? So basically, when it asks you stuff like, oh, there's minimum k such that you can do it, that means that there's a what that means is that that means that at a small k, for example, in this case, let's say k is equal to 1, it's not possible. And then it becomes not possible, but and then it becomes possible at some point, and then all time after that it becomes possible. So in terms of true false, you can think about it as like false, a lot of false, and then a lot of true afterwards. And we're trying to find the first true point that it is. And of course, and really the only two cases after that, right? Meaning that it's either we are at an F or a T, and then we just kind of divide that way. That's basically the idea behind binary search. And yeah, so the way that I always set it up, though sometimes not quite the best way, is that we try to figure out the bounds for it, right? What is the maximum answer that this goes to that it can be? So let's take a look at the constraints. Constraints, H is 10 to the 9. There's 10 to the 4th piles. Each pile can be 10 to the 9 as well. So that means that, let's say H is 1, maybe. Then K will have to be, and piles is 10 to the 9. Then, wait, sorry, let me double check on the thing real quick. And piles up on. Yeah, okay. It's just like a rounding thing. I just was looking up the rounding rules, but yeah. But in any case, yeah, I think if H is 1, then K will be really big. In fact, there's 10 to the 9 times 10 to the 4th, so there's like 10 to the 13. So maybe the answer is like 10 to the 13 or 10 to the 14. So that we can probably, choose something big. Oops, just to kind of be safe. The way that I always do my binary search is with inclusive bounds, and what I mean by that is that left is a possible answer and right is a possible answer. So when they converge, that range is only one number, and that is a good answer, right? Or that is your answer, right? And of course, here, it also makes it easy because you don't have to worry about left or right. They're the same number. And then mid is equal to, left plus right over 2, the middle. And then if good of mid, then basically what this is saying is that, okay, let's say we found a true value. What does that mean? Well, we found a true value. That means that the value is good, so we want to keep that inside the range, but we want to make it smaller. So that means that if we have, say, this is the range, then we want to move this V to here, right? Inclusive, because, well, it is a good value. So yeah, right is equal to mid. And else left is equal to mid plus 1, because if this arrow is on F, then we want to actually move the left to not this space, but the space to the right of it, which is mid plus 1, right? Something like this. Pretend that the ASCII art is good enough. right? So that's basically the idea behind how I structured this, in case you're wondering. And then now we have to do the good function, right? I always call it good and target. And here, basically the target is the k, so that means that for x in pios, so let's just say hours is equal to 0, and then x, so hours we added by x divided by target, but of course we want to round up, so the way that we round up is by adding target minus 1, right? You can kind of show to yourself why that is. I'm not going to show it. I'll leave it for you as homework at home. And then now we want to make sure that this is less than or equal to h. Is there like a -1 answer or something? Oh, no, I guess you can. Oh yeah, h. Okay, yeah, h is at least the powers, and that should be good. Let's give it a run. Let's give it a submit. Oh snap. I guess k. Okay, fine. Silly mistake. I was okay, fine. Made a mistake here because I assumed that left can be 0, where you cannot use k equals, because like I said, this is an inclusive bound, so it makes debugging easier, because when you see 0, you're like, okay, actually 0. I just didn't think about it because I skipped ahead. But when you see, yeah, they're inclusive bounds, and left cannot, or k cannot be equal to 0, because, well, if k is 0, then you're not eating anything, and this becomes infinity. You can also write like if target is equal to 0 or something like this, but either way. Yeah, so this is going to be O of log r, same as yesterday, I suppose. If I could type it out. Where r is equal to the range, which is 10 to the 15, or 14 maybe. And of course, each of these core is going to be linear time. So this is O of n log r time, and O of n O of 1 space, because we don't really use that much space, we just use variables. So yeah, let me know what you think. I think the major shift with this problem, I mean, I guess we did it yesterday, so it's kind of hard to say it today again, but the major shift is that now you're searching for an answer and figuring out a way to justify that answer either as true or false, and then try to do that in as fast as possible. 10 to the 15 is, what is that? So 2 to the 30 is 10 to the 9, right? So 10 to the 15 is that times like 1,000,000, so that's 2 to the 50, say, right? Give or take. And so that means that this loop is only 50. 50 times n is going to be fast enough because n is only 10 to the 4th. That's how I would do my math. Usually n log r is probably fast enough, unless you're really searching over a huge space, or you're being sloppy with the test function or something like that. But, you know, anyway, that's all I have for today. That's all I have for this problem anyway. We'll do the weekly ones afterwards. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later, and take care. Bye-bye.